Hello there, my name is Chris Kerswell, and in this presentation I want to go through the importance of data masking and what the Redgate solution for that looks like on the Oracle platform. So I'm going to do that by going through the, history of where data masking has come from and why it's particularly important right now. And then I'm going to show you a quick demonstration as to what that actually looks like and how we can enable that on the Oracle platform. Alright, so first of all, I want to talk about the rising tide of data breaches. The idea of a data breach is just something that has really grown in the public consciousness over the last 10 years or so, I guess. As organizations capture more information about individuals for marketing purposes, for, well, even political purposes, there's a huge amount of data that is owned by companies effectively on our behalf. And that there's now, I guess, the idea that that information is of value. So you can determine a lot about an individual, you can determine how best to market to them, and you can also use it for slightly nefarious purposes as well. So for example, if you are taking your workout data, something that seems quite innocent on the surface, let's say you go for a run every morning between 8 and half 8, that data can be used effectively to profile you to determine when you're outside of your house, and so maybe that's when an individual might target your house. That sounds like an extreme example, but that is a tactic that's used when organizations are targeted by individuals looking to essentially run fraudulent invoices at them while board members are away on, say, business trips. Alternatively, you have the concept of identity theft, really, taking someone's information and again using that in a fraudulent way, maybe creating fake credit cards, that kind of piece. So individuals' data is valuable, and losing certain bits of information can be really damaging to individuals. But also from the actual organization perspective, if you are subject to a data breach, that can mean significant loss of face, it can mean a loss of users or a loss of custom, and it can also have legal impact as well. Now there's a couple of different routes for that. Maybe you're going to get sued by private entities or a collection of private entities, or alternatively we have legislation in place now that's been put in by governments to effectively try and protect their citizens from a data breach. Okay, that makes sense. If we accept that the role of a government organization is to protect its citizens, that's now one avenue that they're going to look to do that. The GDPR was a great example of this. So a few years ago this came out. It essentially mandated, with quite a broad scope, that EU citizens have some fundamental rights when it comes to their data. Essentially it boils down to the fact that you can't use their data without their consent. This isn't just the EU though. We can see other bits and pieces popping up globally that are particularly relevant to this. So for example, in California, in New York, in Australia, in South Africa, and in Brazil, we've seen very similar bits of legislation that are essentially there to try and enforce that. And that's not even considering the specific verticals where there have already been very strict data protection legislation in place. For example, if we think of PCI DSS and so on. But individuals, especially developers, maybe testers as well, still want copies of effectively production to run tests upon. So how are we going to do that if, legally speaking, that's now a grey area at best, really? So this is where data masking comes into play. We're going to transform a dataset into something that is effectively usable. Generally speaking, there's two different types of data masking in the market today. So there is this idea of static data masking and dynamic data masking. At a high level, the difference between the two is where the focus lies for the obfuscation of data. In static data masking, we take the simple approach, which is where you essentially just transform the data at rest so that it's all a safe batch of data for you to use however you want. With dynamic, you put in a bit of logic in between so that any query that's returned is transformed dynamically into the data that's usable but in theory safe to use. We at Redgate, we much prefer the static approach. There's a couple of different reasons for that. One is it's the simplicity of use. Two is I personally would regard it as a little bit safer because it does mean that one copy can effectively be opened up. You can put it on the cloud, you can put it wherever you want. If you lose it, it doesn't really matter anymore because you cannot revert to the original form. You cannot reverse engineer the original data. You cannot access the personally identifiable information that we're trying to protect in the first place. So I'm going to go through our solution for static data masking, again on the Oracle platform. So the three big focuses of this: we want to ensure that we're going to be compliant with relevant legislation, such as GDPR. We're going to look to be able to provide this in a repeatable way for, say, developers to use copies of production. And we want to be able to customize these rules as much as possible to fit our unique data sets. So now I'm going to go through a demo of what this looks like, and we can take a closer look at the solution and how this applies to an Oracle series of Oracle tables. Alright, so opening up my VM, I've got an Oracle instance here, and in this particular schema I've got two tables full of personally identifiable information. But of course in this case this is generic or made up information. I wouldn't be showing actual PII here. So for example, we have people's names in the first name column. We have people's surnames. We have then addresses, but critically that address is spread across a series of columns. It's not just one column that contains that, and we tend to see that quite a lot. We also have email addresses, and we have phone numbers as well. So all of that information we're going to want to transform. I'll show you how we do that. I'll also show you how we can make sure that any data that effectively hasn't been normalized fully can also be handled. Important to maintain logical consistency at all times, so that's what we're going to try and achieve here. My contacts notes table, therefore, I want to also keep in sync. So how we're going to do that is by using our data masker application. What this does is it creates for us a framework whereby we can run rules over that data set. So these four rules form this quite straightforward data set here that's going to tackle that problem that I've just surfaced. Right at the top we have the rule controller. This contains the connection information. When you run or create a data set for the first time, you'll go through a wizard and this will populate that. And then we have our three following rules: our substitution, row internal, and table to table rule. I'll go through each of those in turn. Important to note that fundamentally the way we approach data masking is on a data set based approach. So what that means is that we have these data sets that we can use for that. So we have a large amount that come out of the box. You can see an example of that here with company names if I hit sample. But basically these are just very large lists. So you can see some generic looking company names For example, we have Perceptions Bainbridge Limited or Areas Thundar Company. Another cool thing is that you can create these yourself very easily. They're essentially just CSV files. So create them, put them in the correct directory. So we have the directory for datasets listed here. Refresh this, and then that's good to go. So the rules themselves then. First of all, we have a substitution rule. This is probably the most straightforward of rules from Datamasker. The idea is that we basically take a column like the first name, last name, and address columns, and then we map those to datasets. So whenever the rule sees a particular entry in a column, it replaces it with the data from the according dataset. For example, here then we have first names, that's replaced by this first names dataset, surnames with surnames, street addresses with street addresses, and so on. A couple of nice things here. So one thing is that we can create a full address effectively by using a specific type of dataset that we call a correlated dataset. And what that allows us to do, you can see here for address 2, we have chosen the town option, whereas for address 3, we've chosen the county option. And for zip code, we've used the postcode option. So that effectively contains a full address. You see it's delimited by pipes. So if I focus on one of these, for example, Hull. So for those of you not from the UK postcodes, the first 2 letters usually reference the region it's in. So Hull, HU. We're going to apply then the HU postcode in the appropriate place and the Hull location in the appropriate place as well. Alright, so that's our substitution rule. That's going to do the first run in effect and give us the bulk of that data. The second one we're going to look at is a row internal rule. And that's going to do something a little bit more sophisticated. It's going to be generating an email address. So you can see the email column is what I've highlighted here. And we're creating essentially an email address by taking the first name column, substringing it, adding in the last name column, and then putting in at email.net at the end. So that's a very basic example, of course. We're just creating emails with at email.net. You could augment that further, put in a little bit more sophistication. Maybe you want to link that to a parameter. So for example here, I could call out to the parameter DMO param1, link that to a dataset. I have seen people use that to create email addresses, for example, where you have a random word and you put that in instead of the word email, and then a random SLD instead of .net at the end. And then finally, we have this table to table rule. This is going to synchronize those 2 tables. So we have our contacts table and our contacts notes table. And what we have here, quite conveniently, is a nice join condition. That's the contact ID in both tables. Now, we don't necessarily need that. If we didn't have this, we could still use this approach, this table-to-table sync. Just wouldn't be quite as efficient. And then we simply map the first name to the first name, last name to last name, and we're done. Okay, so those 3 rules, good to go. I'm going to hit run, and we're going to run those rules now. Now if we review that in our tables, so let's start off with our contacts table. Important to note, contact 1 at the top is Brittany Shearer. So let's see who that has changed to now. So now we have at the top a Lally Strauss, who now lives in South Croydon in London with a CR postcode that matches the area. We can also see that we have an l.strauss email, and that is a new phone number as well. Similarly, if I look at my contacts notes table, again, we now have Lally Strauss being our contact number 1. So that's a quick look at the data masking for Oracle application and how we can use that to create that data set. If you've got any questions about any of that, please feel free to leave a comment below or contact me via my email address. Happy to answer any questions you might have or help you getting that set up. For more information, you can also always go to the Redgate website, and don't forget to check out Redgate University for more videos, more content like this. All the best. I hope that was useful.